Good morning, Jeff.
Morning, Sammy. Oh, wow. And I thought I was late.
Um, yeah, generally it takes 5 minutes or I think it's set 5 minutes or 10 minutes after. Generally, like people rolling over from other meetings. And also, I thought like if people are joining from East Coast or even Europe, it makes sense to get the meeting over at least rather than later. So I left at 8 o'clock. So, are you going to be there in regional summit, Jeff?
No,
Okay.
no, it's I can't get travel approval for something like that at this point. But I actually was just vacationing in northern Spain just last week. So
Oh, you were there already. Okay.
yeah.
Good.
Well, another 2 weeks and a little more southern latitude. The weather should be really nice there. So it was a bit on the chilly side for us, but it was okay.
Okay. Okay. Yeah, this week I was not able to get some of the things I was kind of hoping to get some more progress on the profile stuff. But we also had some standing uh, discussions that we want to have on the network and storage, and I thought like we'll.
Yeah, so Sammy, the document that we showed last week, I couldn't find it. Is it posted somewhere?
No, I don't have a clear locations where we can post the material. So do you have some storage somewhere?
Well, it's the OCP wiki, they should have you should be able to put documents up there in the honestly don't know how it works.
Because when I was in the FTA side, we used to have a SharePoint, like Google SharePoint,
Well,
where
yeah, there's that. Yeah, it gets shared on Google Docs, but then the link is posted on the wiki or in the documents, pages on the work group thing. It's yeah, I can't place a blame on that on anybody because it just seems like these web collaboration tools just still don't actually work.
yeah, another thing probably possible you can add to the GitHub as another document. Maybe people can have access to
Well,
that.
yeah, GitHub's much easier, but that's
Right.
yeah, but I don't know if it doesn't work. I mean, I don't know what format you got that documented. If it's Word docs as
Right.
other binary things, but GitHub doesn't know how to deal with those very easily.
Oh, is it?
You can still post it, but it just
Right.
it
Okay. Yeah, I think need to find a thing. Maybe I can send it to you for the mail and the. Uh, given that was the way I kind of organized, it's more of a discussion thing, not nothing final. So
yeah, but yeah,
like,
what I wanted to do is I wanted to get into that discussion about the make sure that I put into the profile, all of the things needed to get the new efficiency metric.
okay.
Um, and talking with the other folks uh in the in the uh in the other work stream here, that we want to make sure that the sustainability profile is something that everyone can pass today, given as long as they have power or energy measurements available, we want them to be able to get a check mark on that. And since your efficiency metrics, is asking for new measurements that may not or probably not available from the hardware in existing products, I want to put those as recommendations so that somebody that doesn't have the fan power or the VRs exposed, they can still pass the profile today, call that version 1. But they see the recommendations that say like, hey, you don't meet all these recommendations, but that's okay, that's acceptable, you still pass. But we set the path and set that expectation of you should not expect to pass this when we go to version 2 or whatever the follow-on version is called that will make the efficiency metrics a requirement. So I think that's a better path than having multiple profiles. We'll just march this one forward in time. And I say that because we're gonna be lucky to get people to pay attention and give us a check mark, or worry about passing, one OCP profile. I don't think we want to try to get two separate ones. So I kind of want to say, like, look, your product, meets the OCP, sustainability requirements, period. And then, guess what? Those requirements, got more difficult, in 2025 than they were in 2024 or whatever. But get them on that path, and then they feel really bad if they fall off.
Yeah. So then let me I will add this to you. So I just copied to one of the folder that we had as an existing one. What is the email that you use?
You can send it to jeff.otter@hpe. Here, let me put that in the chat.
Is that generally accessible through the Google Drive with OCP?
Oh, actually, why don't you use my OCP one then? That's make sure I get it right. I'm trying to remember if it's yeah, I'm gonna copy here. It's Jeff.Otter at OCP project. I'll put it in the chat.
Yeah.
Come here. Yeah, use that. That should work on the Google Drive.
Okay. Because generally what I heard was that not all the emails work on Google Drive, at least OCP Google Drive.
Yeah.
Right. I send you the thing, see whether you can able to access, or I can also type that. Hi, David. Good morning.
Morning, guys.
Yeah. So I think about not seeing a crowd today. I was hoping Eric, Shruti will join too. Eric had a lot of comments on the network side. Let us probably start the discussion. Any opens today before we can start?
Do I have anything?
Okay. So let me quickly check on. So today, I think what we would like to, let us spend some time here to go over this couple of items. I would like to get your feedback before we can go and say that it's going to work. Let me see which one I see sharing. Yeah. Are you able to see this network and storage? Okay.
Yeah.
So we were discussing, I think, last few meetings related to the IUE for compute, or can be for any general system, but there was a question related to how do we deal with the network and storage. And when we started with the computes, we need to really like thermal power and power conversion loss, ID loss, we want to remove from the system and use the remaining one for compute. And the rack level, given it's generally compute as a kind of self-contained, for moving to rack, it's just a addition sigma of all those things, and even DC we set sigma of all those things. But when we started discussing on the network, even storage, there was a question on how are we going to account. Even before going there, let me probably share a picture of those. It's easy to talk with it, right? If you are looking at storage, right, there are multiple drives in the system, and in order to create a RAID or a redundancy, you basically like use multiple drives to kind of represent that is a system. And even though it is within the system, you may do the redundancy or a RAID other thing within the rack itself, or you may even go across the rack. So when you go across the rack, then basically if you are really looking at the services it provided, it is you are communicating from compute, you are talking to some of the storage service. So we don't have a clear accountability of who's using what, which compute is using what. If you really like take a system and say like, these are the things I'm going to be using from external to my box. And if you want to account it, right? That is one of the areas. So then I think the question is, let's talk about storage, then we'll go to the network, right? If you look at just a storage box, it's built using, I just put some text here for us to have a conversation. It's nothing written stone here, right? You're building a storage using compute building blocks. And for a IUE, you could say like, take all these things that we put for compute, it can be applied for storage. And you can say even storage system is, as long as system IUE, we can storage or compute, it's the same. That is one way of accounting it. Or then we need to say like how much it's really used by the compute within the rack. When you put a, let us say, a rack IUE, if the storage sitting in that particular rack, it's really servicing outside that box, outside the rack. Yeah, even though we are accounting that IUE with it within the rack, is it really make sense or not, right? If you want to make actually how much compute is using within the rack, and always this storage assignment is more dynamic. Really, like you might use for a short period of time, and it will be given to somebody else, and there is no clear mechanism or metrics to say like who's using what out of the storage boxes. And the questions to this team, do we want to even start discovering and accounting for it, or we want to kind of say like, as long as it is that system is like, for example, sitting in the rack, or even the storage system IUE, can we compute like as a compute system IUE? And when you have multiple storage arrays in the rack, can we aggregate together like what we are doing for a compute and say like it's the IUE coming out of storage is accounted as a rack IUE, even for data center level?
Think about this too. My first thought
Right.
is it's hard to align the compute with the storage in a rack because that storage may be shared between multiple racks, right? Just how it,
Correct.
just how you're showing it there. So I'm struggling at the same time with how, without any way to kind of measure. Okay, there are some storage devices, I'll call them storage devices, that have compute built into them.
Mm-hmm.
If maybe we could put a caveat is if there's compute that is used to do the computational, choice pieces for your storage, that could be part of it. Just thinking out loud here.
Yeah, go ahead. I think I want to put it as a brainstorming session, right? It's really like throw the ideas and see like what we really want to go after, right? So what you're, if I replay it, right? If it is the storage is used within the compute, it's already accounted within the compute. But the question is outside the compute. This compute is using some storage here. How do we want to account, right? Maybe it's going from here to here. And maybe only one. Then it's easier, right? This particular person is using this one. You can basically say like combine them together when you're calculating IU, right? But
Correct. Yeah. But then you have to keep the person who's calculating this has to keep track of where the compute and storage are related.
right,
And in some topologies, compute and storage maybe it's really hard to track that depending on using multiple storage technologies, you know.
right. That's where I see the problem, right? How do we want to first of all take a position to represent, or we want to say like no, let us not. We acknowledge that fact it's happening, but ignore it, right? So if we can say like this is shared between these two. But even then, how much shared, right? Is it 50-50 or is it 30-40 or is it dedicated or is it dynamic? Depending on need, you may get a more or you get a less, right?
Correct. And I think that maybe here's a suggestion.
Right.
If we're looking at it at a device level, right, and that device is all 100% storage, but that storage requires basically compute to process things. So it's basically, think of it as the compute and storage, the box you have here, this compute, storage, and network,
Right.
is the storage, I'll call it storage subsystem, just, and that is using, and that has its own compute to process the storage being requested from some other compute environment, right? So if
Right.
the compute is 100% dedicated to processing in and out for the storage in that box, that compute then is directly aligned. If the storage is not 100%, then I don't think there's a way you can calculate it, right? In any way of what the IUE of that storage would be.
Right. Or we can say, as long as sitting in a box, I just calculate IE for your storage without really accounting who's going to be using it. Then it makes it simpler for a rack level compute, right? I could say like storage IE is calculate similar to the compute IE is nothing but whatever the compute resources used within the storage, that's what you want to account for it, right? Compute plus whatever the storage elements. So I think if you go back this one, right, we can even bring this 3 here and say like this is built on top of the CPU. We can say it has the thermal and all the losses, and we can say it's a storage compute here, right? If I change the color to green.
And that's
This,
and that's viewing it at the rack level.
Right. This one you're looking at system level, then it's kind of duplicated for every system, right? So if you put a box around this is a storage system, right? We can basically say like the storage system contains these elements. Storage contains nothing but storage compute, storage network, storage array or elements, right? So we can really remove these 3 easily. The only thing is out of this compute, all this, the bottom layer that is coming here, right? Because storage itself is not using by itself, right? It's used by somebody else. I mean, it can be within the rack or outside rack. The question is, do we even worry about who's using it, or as long as sitting in my storage, I will, I mean, my block, I should account for it. That's all right.
Oh, that's a good way of thinking about it. Is if it's sitting in part of your, how would I call that? But your estate, maybe.
Right,
Then it's all grouped together. Then yeah, you have to account for it.
right. It is sitting in my area, but I'm giving the power to them. I need to be accounting for it. Some way of accounting does not seems right, but also that is what it makes it easier, right? By sitting in my rack, I will account it. I don't care who's going to use it, right? Even if you compute, sometimes people can argue, is it compute used by managing services within the network, or it's used by external customers, right? You can argue, like, is it really translating into real computed by end customer or not, right? If you put that argument, then yeah, the storage is kind of similar way, right?
Correct. I'm just thinking about it in my head. So I think of extreme cases. So you could have a whole frame that has one compute, but it's pulling from all the any storage, and it could be any storage media.
Right.
And then yeah, it depends on how active that is versus because especially, well, like I said, if it's a one-to-one associate, it's really easy. When you start sharing, like you said, when you do the sharing that you're showing there, right, where storage is shared across, it makes it a little harder to calculate that storage IDV. So, but I think yeah, we'll have to make some assumptions. I think that's the only way to move forward, right? Making this assumption, this is how you would move forward with calculations, right? Using the, like you said, for example, where you have the thermal power, Persian loss and idle power, and then just changing it to be specific to just the storage subsystem. Now, something I have to think about some more, but logically it makes sense when you just look at it.
Yeah, I think that's true. So Jeff, do you probably be working on a description of storage and SNIA and some of the what is it, SWOT trace, right?
Yeah.
Do you know, like, how is that kind of represented? Are they really like care about who's using it, or?
Right. So I mean, so looking at those boxes, and I have to map this into, an actual measurement point, right? So to me, there's two categories here. There's things that map directly to a power energy. I'll just use those interchangeably. So I have to have a measurement point somewhere to get a value. And so, at the box total, that's the easy one, or the well-known spot. For historical other reasons, we have measurement points sometimes on the processors or on the individual processors, or sometimes individual memory and things like that. And so the questions that have come up for sustainability was to go add additional measurement points to find, to be able to go get that thermal power loss, or how much power is being consumed in thermal management. And then I think the newer one is power conversion losses. We already have that in the power supplies, but I think those numbers have gotten to be very small relatively because of the efficiencies of the power supplies, but that attention was not spent on the DC converters, and that's where that conversion loss, I think, is non-trivial, especially according to Eric. I haven't validated that, but I believe him because the amount of power that's moving through those regulators now is substantial. So even a few percent of loss, can add up to many watts. So anyway, that's when I look at these things and map back to what sensor, where am I getting this measurement, and the one that sticks out to me that's different. And that's okay, but the question is, how do we report that? And that's the idle power, because that's essentially the same measurement point, as the system at a whole under load, but just basically at a point in time when it's not doing anything. So I think the question is going to come up is, is that something that is calculated? Is it stored? Is it reported? Because it's not a separate measurement. It's a measurement at some point in time or under some condition. Because you're taking that measurement from the. I mean, the way we do this today is, you ensure that there's no load running, and I look at power consumption, and then you'll do something to go, run the unit at its highest capacity. Running, trying to run at 100% utilization, and then get and get a power measurement there, and then that becomes your bookends. So that's going to be my question: is how do we expect this idle power to be reported? Is that something that just going to store off somewhere and say, well, this is the value for this system, and I don't have an issue with it. That's fine. And it may just be thinking about how we have these things rendered today in the redfish model, for instance. There is there's the ability to store the minimum and maximum readings of a particular sensor in the model. So idle power could effectively just become the it's the total system power sensor, and it's the minimum, is it just the minimum value that sensor is already seen? That's your idle power. That to me would be pretty, that correlates to me pretty well. And obviously those things can kind of be reset if you do like a major system configuration. I mean, if you, the idle power, the first time you turn the unit on and you come in tomorrow and install, 4 GPUs, that's going to be a little different, but that kind of stuff notwithstanding, that could be our answer.
Yeah, I think idle power, we had some conversation on how do we kind of deal with idle power. The thoughts were, I think I can even paste the slide here from this one. Basically, we basically said like can be a static. That vendor is putting my idle power is static number, or dynamic in the sense during boot you do kind of measure the number and represent that as part of your system. And also I think there was again the sharing is one of the areas we were talking about. How do you deal with it, right? For example, you could have a hard swap unless you add additional hardware component, your idle power is lower. But later, when the system is running, you added some additional storage array.
Yeah.
Right. Then it adds additional power that also you need to add something to the idle power thing, right? And also the network and share storage, all these things. It kind of makes it a little complex. But at least we wanted some minimum number that we are kind of talking about, right? Min, max, but min can be a ideal power, not a 0, right? We don't want to put a 0 on the min.
Right.
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 And actually, so my other question for idle is that idle at the system level, or at the full unit, or or are we, or are we going to want to subtract the losses, meaning the inefficiencies, so I hadn't thought through this in my head. So for instance, if I take, I could do it either way. We can say, is the idle power the operational componentry at idle, minus, so that would be idle system power minus idle VR losses and minus idle speed fans.
Yeah, I think that is a complex, right? The analogy I have is when you have a car, when you started the car, but you are not start driving,
Yeah.
it's idle, right?
Right. But so I just need to know where the subtraction is going to occur. Are you taking idle power again, from a measurement point? Is that like the total wall watts being consumed, or is that after I remove the overhead, the fans and VR losses from that total?
So what we want to, if you don't want double account, right?
Right.
If you are already accounting idle power as part of the fan and thermal, then you want to put that kind of zero. There are this idle power have these two components. It's depending on how you represent that, right?
Yeah.
The ideal power can have a real ideal power plus the fan and this one.
Okay. So all right. So yeah.
That is one way.
Yep.
I would say, like, let us keep this two separate.
Yeah.
So that you're not double counting. Then subtract the, like, for example, if you booted the system, it's still ideal. And if fan is consuming and VRs are consuming, we are already accounting in that things. Let us put the subtract those number from that wall power and put it here, right?
Yeah, I think that makes sense because now you've got effectively the piece in green there is effectively the workload, and so that's
Correct.
what your efficiency is. So I mean, yeah, if you're sitting at the as you said, if you're sitting in a car at the stoplight, the engine is running, that's inefficient because that's your idle power. And so now when I jump on the gas pedal and get up to 150 miles an hour, well, that's all in the green box. And that's
but also the thing is, are you running heater? Are you running AC or other things, right? How are you going to
Well,
control
that those numbers are still going to change, but that idle becomes
Right.
that baseline that you still subtract off. So
Right.
yeah, there's going to be increases in the thermal power and the power conversion losses because you're running all that, running the AC and all that stuff and the radiator, blah blah blah.
Right.
So yeah, that will account against you, but but kind of coming back to where's my zero state. And so yeah, I think what you're saying is everything outside of the green box there would be considered inefficient power consumption.
Correct. So when you are running in ideal, you want to kind of account all the three, but if we are already accounting a separate one, let us not
So I mean,
double account, right?
If we stretch that, if that box, was representing a very, the green box would be effectively zero, right? At idle. And so if we take this, then we move it to 100%, that green box gets much bigger, but the orange and the light blue boxes also get bigger.
Right.
And it's the idle power box would remain the same. So that becomes a static loss.
Right.
And yeah. Okay.
So I think we need to clearly spell out that things, right? I think that is one of the discussion we had, and we said, like, we need a clear definition, otherwise people will misinterpret it, right?
Exactly.
Right.
And Sammy, did we already sort of narrow down how the idle is being, calculated or measured? Like, did we say it is the system level, you put the entire system into booted but idle condition and then measure?
No. Yeah, it's system, your boot, like, there's two things, right? What we said was, you could, if you have a mechanism to during boot, you can measure ideal, you can compute it and put it. or the system vendors need to carry a static number and say like, hey, this is what I'm kind of saying, static. I don't have a mechanism to compute. You could have that static also.
And that static one is more like, what is the static power for all the components, all the subcomponents, and sum it up.
Correct. What you're providing or what you started with the system, but I think the accounting of hot plug and other things, it's a challenging one. But if you are going to have a per device power or something, or if you want to say like, whenever you hot add, I'm not going to account for it as part of the booting the system, then that is a little misrepresentation, but at least we can say clearly define and say it's not accounted.
Sure.
At least we can say that is a gap, but it's not accounted there. Right?
In case of static, they will be able to account for, when there is a hot plug change. They can change
static will not account, right? It's even
No.
the dynamic one when during boot, the difference between these two, right? The dynamic one, let us say I built one system and let us say customer can add additional component on top of the system, right?
Right.
So this will able to detect this case that maybe one system with 2 SSD, another system with 10 SSDs and some network and some GPU, things like that, right? So that dynamic probably able to deal with it. If you put a static, it will say, I'm going to give only base numbers, but anything added is not calculated as part of it, right?
Oh, I was thinking the opposite, because in the measured or the dynamic case, the boot and the idle measurement is happening once. And after that, if there is a hot plug, SSDs are added, for example, that was not the state in which the idle was measured.
Now, even
But in
dynamic,
static,
what I mean to say is measured, or there's two type of dynamic, right? Boot time that you are able to calculate and give it. Or even you can say like whenever a hot plug happens, that I will adjust the number dynamically and say my new dynamic idle power is different from my what I booted with it, right?
Oh, so we are saying whenever there is hot plug, or in this example, SSDs are added, they should go back to the state of, as if it's just booted and not doing any work, and measure again.
Not
that
measure,
would
right?
be.
You can represent it, right? I'm just throwing some ideas here, right? Dynamic A. So if I say it right, dynamic A, option A is the boot time method.
Yeah.
And B is still boot time plus accounting for hot plug, right?
So how is that accounting for hot plug again? Because my understanding is that in dynamic, we cannot account for hot plug because dynamic is measured.
So then if you want to account for hot plug, each hot plug components, devices need to provide what is my ideal power for that.
So you're going to add it?
No. I'm just throwing an idea. I'm not saying we will do it.
Okay.
But I mean, possibilities, right? If you think of possibilities. So
essentially, when there is a hot plug change, do we agree that theoretically it might be okay to say that, there can be another measurement as, bringing the system to idle, but practically that might not be possible?
No. I'm not saying bring the system to idle.
Yeah.
When I hot plug a device, as part of the hot plug, Zip, correct me if I'm wrong, each device could have their thermal power limit, right?
Right.
If you are already putting the power limit as part of that, they could also represent my ideal power for the device, right?
So each device has its static idle power.
Correct.
Are you suggesting that should be added to what was measured on the initial system?
Yeah, that is one way. One way, if you want to say, if you want to be pure on your ideal power, then you need to account that as part of that. Or if you want to say, whenever hot plug device is getting added, I'm going to treat as a 0.
Oh.
Then you are not accounting for as a hot plug at all, right?
Yeah, then you're not accounting for hot plug.
Right. In the ideal time, you are basically accounting everything in runtime, right?
Okay, so that is one suggested way also.
Yeah, one suggested way. Right. I think the question to ask is, in a data center, generally, like how much you're really doing hot plug, right?
Exactly. And usually it's all
Okay, so,
cabled together too.
Right.
And it's really hard to do that.
Right.
The cams
Right.
may all spin up and yeah.
okay, so these are essentially what I heard were like four different ways. One is, you basically measure at boot time when system is idle, and afterwards you're going to ignore hot plug.
Right.
Second is, you measure when system is idle, and you can add the static value of the hot plug device. Then
Static
you
value
can
or
go
the
completely
dynamic
static.
value coming from the device. So whenever you hot plug,
Uh-huh.
the device will represent the number as part of that hot plug operation.
Oh, okay. Yeah. We can add the dynamic value from the hot plug, but basically there has to be a summation activity to get to that.
Correct. And
And
today we
then,
already have, right? Because there is when you hot plug, you need to say what is my power I'm going to consume it, right? You don't want to hot plug and trash the system, right?
right.
So what
Yeah, no,
I'm saying is
that
you could
part I
add
agree with.
additional parameter, additional metrics on top of that to kind of account for it. Yeah. Go ahead.
But
You
that
want to say something?
additional
Yeah.
that additional metric would be added when the hot plug is added.
Right.
Correct. Yeah.
Right.
Okay. So sorry, coming back to what are the different methods we are saying? Either you do dynamic, idle system measurement and then ignore hot plug after that.
Correct.
Or you do dynamic idle system measurement, but the hot plug component is manually added when the hot plug comes in.
Correct.
Or we are saying everything is static, you are just getting to the idle value by adding up all the subcomponents idle, in which case the hot plug can be added in when the hot plug comes in.
Correct. All those are possibility. We need to finalize what we really want to recommend, right? These are possibilities we are putting.
Sure.
And what we really want to finalize and recommend as part of our schemas, I think that's what the profiles and schemas that we are going to create. We may say like, let us start with static so that even existing product can easily add this item easily. Maybe dynamic is profile, I think Jeff saying, right, version 2, version 1, version 2, version 3, you can add additional things to make it much more clearer in the future versions, right?
Are we thinking the idle measurement will happen at system level only?
No, need to happen if a system level is able to represent here, right? And when you do the rack level, then you are coming to summing up all the ideal from every single node. Then you get a rack level, and even you can get a DC level if you want, right?
Sure, system or rack level. We are not thinking of it at a node level, meaning one
Now, system
server
is a
level.
node. System is node. I think Redfish representation, each system is a node.
Oh, we are sort of thinking that each node is
Correct.
booted and put in idle.
Correct.
And then measured.
Right. You don't need to put in idle. Like while booting, you can compute the number and represent it, right?
Sure, but each node idle is, which might actually be, the rack's total idle power getting split over the nodes.
Correct.
Okay. Yeah.
It's basically sum of all the nodes idle power is your rack idle power, right? But again,
Yeah.
whether that node is on or off, you need to account for it, right? Because let us say I have 10 compute systems in a rack, but only one is on, then your rack current idle power is only one system, not 10 systems, right? So it's a
Okay.
dynamic value when you query it, right? It's all depending on how many are on or active on there. And even today, power is something like that only, right? When you ask for rack power, even though you have a system sitting there, but if other system is not sitting there, your total consumed power, you need to account for what system is running.
Sure.
So, yeah, going back onto the IUE side, I think, are we kind of aligned? Do we want to ignore the sharing portion right now? Or do we need to do any work on whether it's shared or whether it's shared within the rack or outside and reference that?
And the only other way, just thinking here, the only other way to look at things is to say capacity consumed for that device, right? If it's fully consumed or not, that, or even the throughput, right? Or a combination of those. If that's changing the dynamic from what we're talking about here, but
Right.
that's another lens to look at, because I think we're having kind of the same issue with networking. I don't want to go to networking quite yet, but it's another way to kind of look at that storage versus looking at compute.
Yeah, I think the question is it statically assigned or is it dynamically in nature that changes, right? That's where I have how do we able to deal with it, right? Even today, Redfish, I don't know, Jeff, is a storage bandwidth or is it available or how much it's really consuming?
This I have to see that. A lot of those utilization things are difficult because if you're measuring them from the hardware, a lot of those links are always active. Let me see if there's. It's one thing to say that the properties are there. It's another to say that whether or not it's actually, if it's available to be, if you can actually see it.
Right. How to meter these things that's where it gets difficult depending on
Right.
who you are and what access you have to.
I'm looking to see. Oh, I'm sorry. I should be in port. Let me look at port metrics. That would be the.
I think it boils down to network as a similar thing, right? You can when you start thinking about it, right? How much ports are there and how much actively used versus not used. That's how you want to account for that compute, right?
The link's active or not? Yeah.
Yeah. So I think there is some talk when we started talking about it. Say totally bytes transfer. That's what we want to go after.
Yeah, you've got bytes read and written, those kinds of things. In terms of does that get you to bandwidth, consumed? Let me see. I mean, I know I've got some of that here.
Did you have a theoretical capacity of
Yeah.
every device? Same thing with storage. You should have capacity, and then there's a way to measure that.
So then
I have stuff in memory processors, but I'm not seeing it under. I mean, I've got it in switches, max and current bandwidth. Things
and
for
also
CXL.
and also provision, right? Like how much you are provisioning for each compute. And if you have, let us say, storage capacity of, I don't know, just throw some number, right? 10 terabyte or something there. Are we provisioning equally for everything, or is it one compute takes 50%, all the remaining takes another the remaining thing, right? then when we account for the storage, how do we want to split it, right? Because if I put the idle power for that, right? Because you can say like 50% goes to one compute for that particular storage, right? But when you're not that, even though it represents 50%, but the traffic generated by that one compute is, let us say, only 10%. And all the remaining guys, even though they had also adding 50%, they generate a lot of traffic. The power consumed by the storage is going to be, we are not accounting it properly, right?
Yeah.
So I think the simplest way, I think maybe what I'm kind of thinking is in the version 1, we should probably say like if the storage is sitting in the rack, does not matter who's using it. We should just put it as part of the kind of similar to compute IUE, right? Just calculate and add them together. Maybe in version 2, we should start thinking, hey, how do we kind of able to divide and really able to use, say like how much percentage you want to take it out of storage and add to the compute, right? And but if you are looking at the data center level, they might argue it doesn't matter. It's at the end of the day, it's how much energy is consumed by my data center and how much you are losing on this thermal and ideal. It does not probably matter for a data center level, right?
At that level, correct. Depends, yeah.
Right.
Need the large number of devices, right?
Right. So then it's potentially the argument is probably the IUE kind of the compute IUE may inflate if I instead of putting a storage in locally, if I put it outside, then you are not going to consume ideal power loss or all this power loss is not accounted as part of my compute. So the number might look much better. But it is accounted by somebody else, right? But at a data center level or rack level, when you look at it, yeah, it's accounted anyway.
Let me ask you just a general question so it's straight in my head. So let's say if in this picture, storage system compute was at 100%, or we measured at the highest capacity. What would that represent versus it being at, let's say we had we're at idle? What is the IUE number difference? Would it be like I know we talked about that before, doing 1 or higher than 1 versus a fraction. Did we ever get past that?
No, so we basically said the IUE is going to 0 to 1.
0 to 1, okay, yes, okay.
Right, then if you multiply 100, then you get a percentage, right? So 0 to 1. And the maximum you can reach is 1, assuming you don't have any ideal power loss or a thermal loss or a power conversion loss, right?
And that would be with 0 compute happening, correct?
If it is 0 compute happening, yes.
Okay, that makes sense. Okay, I just want to make sure it's straight.
Right. If more compute happens, even with more compute, if ideal loss is 0 and you don't have power conversion loss, then you may have only thermal loss, then it's around 90 some plus you will go there, right?
Okay.
So yeah, start thinking about it. Maybe we may not able to conclude today. I think even if when I started putting some of the network things, the thinking is, yes, most of the networks are fully powered, and you want to keep the ports already powered to kind of reduce the latencies. again, the question is, how are you going to split your network based on the traffic, or it comes down to the similar argument as a storage, right? How much traffic goes into that thing, it's going to matter. But if you are really like thinking about like this system network, also you can put a network instead of a network compute here. It will look like the same.
Exactly.
Good. Yeah, network may not have the lot of storage and other things, but at least it's not sharing. But also from remote compute, you might be using a network and talking to another compute here. So when you're putting that picture, then it's also how do we represent that traffic, right? Is it kind of generated locally, or is it generated from remotely coming here? Who's going to be accounting for that? But even you do a data center level, does not matter. It's a overall it's anyway accounted, so it's not does not matter. So yeah, let us start thinking about it and see. Let us take a stance on like, do we want to just treat it as network and storage is similar to compute? If we can create an IUE, just not worrying about who's sharing what. Or if we want to go down to the path of, yes, we also need to account for how much is shared by who? Then what is the metrics we want to use to represent that sharing? And we will come back and kind of make some finalization around that area.
Sounds good, Sammy. Thank you.
Okay, good. Thank you. So Suruthi, are you going to be there tomorrow in the regional summit?
At the summit?
Yeah.
I'm actually not going to be there in person.
Okay.
My visa is in a state where I cannot step out and enter. It's in a renewing state
okay.
right now. So,
got it. Okay.
but best of luck for your session.
Okay. Thank you. Thank
I
you.
hope
And David,
have fun.
are you going to be there?
No, unfortunately, I'm not either. So that would have been nice to meet you in person, but I'm not.
Okay. Okay. Good. Thank you, team. We will come back and share any updates from the sessions, and we'll continue the conversation week after next.
Yes, please. It would be great to get a debrief,
Sure.
when you attend the sessions.
Okay, I will do that. Yeah.
This is great. Thank you very much.
Okay. Thank you, Tim. We'll see you
Have a good weekend.
in 2 weeks. Yeah.
Safe travels.
Thank you. Bye.